Hi, this is DJB Mathematics, and in this video I'm going to be talking about the cast diagram for trigonometric equations. Now this is the first in a series of videos. This is part 1. I'm not even going to solve any trigonometric equations in this part. I'm just going to introduce what a cast diagram is and what angles look like when they're shown on a cast diagram. And this has been intended for AQA Core 2, but you may find it useful for other exam boards doing A-level maths as well. Okay, so let's get started on this cast diagram method for solving trigonometric equations. So the first thing I'm going to talk about is the trigonometric functions and how they behave, what their graphs look like. So we've got all three graphs here: sine x, cos x or cosine of x, and tan x or tangent of x. Okay, and I've got all three graphs. They're on the same scale. So if you look here, we've got 90 degrees there, which lines up on all three graphs: 180, 270, and 360 degrees. And of course, after 360, these repeat. They have exactly the same pattern, repeating forever every 360 degrees. So what we're going to look at is where these different functions are positive or negative. And obviously sometimes they're zero. We can see that sine of 180 is exactly 0, but we're going to ignore that for the time being and just focus on the general pattern of where each one is above the x-axis, i.e. positive, and where it's below the x-axis, i.e. negative. So let's start by having a look at the behaviour of sine x. Okay, so between 0 degrees and 90 degrees, we can see that this curve is above the x-axis. So the blue curve is above the x-axis. That means that sine x is positive between 0 and 90. Between 90 and 180, still positive. Okay, after 180, it becomes negative. 180 to 270, we've got negative, and 270 up to 360, we've also got negative. Let's look what's happening with cos. We can see that cos is positive from 0 to 90. It's positive again, 270 to 360. But in between 90 to 180, 180 to 270, this curve is definitely negative. So cos x is negative there. Now let's look at the behaviour of tan x. Between 0 and 90, it's positive. From 90 to 180, it's negative. After 180, it's positive again, up to 270. And from 270 to 360, it's negative. It's below the x-axis. And in this video, I'm not going to worry too much about these points. These are the asymptotes of the tan x curve, but we're not worrying about those. What happens exactly at that point? We're just looking at where it's positive and negative. Okay, so if we look down the columns on this table, we'll notice what I think is quite an interesting pattern. So we'll see that from 0 to 90, they're all positive, all three of them. From 90 to 180, it's just sine. The other two are negative. From 180 to 270, it's just tan. The other two are negative. From 270 to 360, it's just cos. Okay, and the other two are negative. So we've got a neat little pattern here for working out where certain values, positive and negative, of sine, cos and tan can occur. But drawing these graphs and drawing that table repeatedly might get to be a bit of a pain. So the cast diagram has been developed to make things a little bit easier to remember which trigonometric functions are positive and negative in different quadrants: 0 to 90, 90 to 180, 180 to 270, and 270 to 360. So it's time we had a look at the diagram itself. What is a cast diagram and how do you draw it when you need it in the exam? Well, here it is. Okay, so it's a very simple diagram to draw. You just draw it from memory in the exam. You've got a horizontal line there, that's 0 degrees at the end there, and then you do a vertical line. So this gives you the 4 quadrants, 0 to 90, 90 to 180, and so on, the 4 quadrants there. 0 is also doubling up as 360 degrees. So when you start there, it's 0, but when you come back round to there, it's 360 degrees, a full turn. Okay? And what I've done is I've drawn on these letters, and again, you just do that from memory in the exam. You start in the bottom right, and you go C-A-S-T. Well, that's where cast comes from, okay? Just the easiest way to remember is C-A-S-T, starting in the bottom right, okay? And once you've drawn these a few times, they come naturally to you. What are all these letters banging on about? Well, if I start from 0 to 90, the A is saying that all of the trigonometric functions, sine, cos, and tan, are all positive. Here from 90 to 180, S is telling me that only sine is positive, okay? Whereas cos and tan must be negative in that region, 90 to 180. T for tan tells me that tan is positive between 180 and 270, and C for cos is telling me that between 270 and 360, only the cos is positive, only cos x is positive. Okay, C-A-S-T, anti-clockwise from the bottom right, spells cast. Okay, that's all it is. We'll look at how to solve equations with it in the next video. For now, I'm just going to look at what happens when we put an angle on here and what this diagram tells us about the angle that we draw. Okay, so here is a cast diagram with an angle marked on it. Okay, so there's the angle marked there, going from 0 up to whatever angle that is. We don't draw these accurately with a protractor, they just represent a particular angle. So this must be, if it's in this section, somewhere between 0 and 90. So I could say, for example, that that was 72 degrees. Okay, so that's marking an angle on the cast diagram. That tells me that the cos of 72 will be positive, the sine of 72 will be positive, and the tan of 72 will be positive, because it's in the all section here. Okay, so that tells me immediately, without a calculator, if I do sine 72, it'll be positive, cos 72, positive, and so on. And we can obviously test that. Okay, so make sure we're in degrees mode, and we'll just have a go at that. Sine of 72 gives me 0.95, so that's definitely positive. Cos of 72 gives me 0.309, also clearly positive, and tan of 72 degrees gets me 3.0776, etc., also positive. Okay, so this diagram tells us very quickly when you've got a particular angle, which trig functions can be positive or negative. Okay, so I'll just do one more example of how to mark an angle on the cast diagram, and then we'll finish up for this video, which hopefully has introduced the idea of the cast diagram. Okay, so here is another cast diagram with an angle marked on it. We can see down here, there's our line, okay, and here's an angle marked of 22 degrees, okay. Now, does that mean that that line represents an angle of 22? Well, no, it doesn't, because we can tell it's in the 180 to 270 section, okay, it's in that quadrant, as we call it, that quarter of all the angles between 0 and 360. It's obviously between 180 and 270, so it isn't 22. If it was 22, I'd have had to draw it up here somewhere. So using this, I can work out what angle that really is. Well, I've got to start my measuring from 0, and then I've got to go around anti-clockwise. That's how we measure angles on a cast diagram. Okay, so if you look here, 0 to 180 is 180 degrees plus the little extra bit there. So it's 180 plus 22. So that line actually represents an angle of 180 plus 22. Okay, it's all measured in degrees. So that's really an angle of 202 degrees. And it's telling me then that if I were to get my calculator out and do tan of 202 degrees, the answer would be positive, because it's in the tan section. But if I were to do sine or cos of 202, they'd both be negative. Only the tan would be positive. Okay, so in summary in this video, what we've done is we've introduced the cast diagram and how that works, and how to plot angles on a cast diagram. We haven't actually solved any trigonometric equations yet, so I've just introduced the idea of the cast diagram, and it's in the next video, part 2, that I will look at how we use a cast diagram to solve trigonometric equations. Thank you very much for watching.